Hello everyone, my name is Doug Baito, and on behalf of everyone here at Tom Tech Academy, welcome to today's webinar titled Pulmonary Hypertension, a Focus on Automated Software. Discussion topics today will include challenges providers face in the treatment and management of patients suffering from pulmonary hypertension, the role echocardiography has traditionally played in the management of pulmonary hypertension, a quick look at the ASE's updated guidelines and standard publication regarding the right ventricle, goals moving forward, and last, the role automated software can provide in regards to the automation and subclinical marker or longitudinal strain. In addressing some of today's challenges, we begin with consistency or potentially lack thereof. Simple measurements being performed by different users almost always result in different values. This can become critical in pulmonary hypertension patients, as you know, due to the fact that the response to treatment and the prognosis of this condition is directly related to the stage of the disease and the time treatment is initiated. In today's busy echo labs, it is not uncommon to have different ultrasound carts from different vendors and or to also have the same vendor, but each cart on a different software version. These concerns can create an inconsistent environment that users oftentimes have no control over. The sum of these issues can, again, oftentimes be we lose the ability to closely monitor patients suffering from pulmonary hypertension and therefore lack consistency. Another challenge has always been the inability to assess the right ventricle due to its complex shape, size, inlet-outlet anatomy, and so on. Attention to the RV size, function, and shape is critical in providing quality care and bringing us to our last point, the challenge of keeping pulmonary hypertension patients in a lesser functional class for longer periods of time. Looking at the traditional role that echocardiography has played in the past in regards to patients suffering from pulmonary hypertension include user-dependent measurements. Even simple measurements such as an internal diastolic dimension, for example, can often yield several different values when several different users are performing these measurements. Relying on visual parameters alone, such as the end diastolic volume, right ventricular ejection fraction, or even the pulmonary artery pressure. Acquiring data using different vendors or carts on different software versions can essentially create an uneven playing field. And last, by relying on 2D echo alone. Great advancements in 3D ultrasound have been made recently, even to the point that 3D echo is now recommended when quantifying right ventricular function by the ASE's recent guidelines and standards publication. According to the recent guidelines and standards publication from the ASE, and to specifically address the right ventricle, I want to touch on a few of the ASE's recommendations. In labs that are currently performing 3D echo, the ASE recommends calculations of RV volumes be performed using 3D over 2D echo. Calculating right ventricular ejection fraction by 3D echo is more reliable and yields a higher level of reproducibility than that of traditional 2D echo. In patients suffering from various diseases such as congestive heart failure, acute myocardial infarction, and of course, pulmonary hypertension, relying on a subclinical marker such as the longitudinal strain trumped traditional means of relying on changes that can only be detected once visible and or relying on subjective data like the ejection fraction alone. In regards to both the fractional area change and TAPSE measurement, we were able to realize the significance in these values even when manually calculated. So having a solution that provides an automated means of calculating these parameters only increase accuracy and increase reproducibility. Currently, no cure exists for patients that suffer from pulmonary hypertension, and thus is oftentimes fatal. Response to treatment and the prognosis of this condition is directly related to the stage of the disease and the time that treatment is initiated. Therefore, our goal remains to keep pulmonary hypertension patients in a lesser functional class for longer periods of time. By using automated software, data collected is more accurate, more reproducible, as the software knows only one way to gather this info and does so the same way time and time again. Explore the value of offline, vendor-neutral, and fully automated software. And last, to ultimately increase consistency, accuracy, and reproducibility in your echo lab. Now, please join me for a real-time analysis of the right ventricle using 4D-RV function. Now that 4D-RV function has been selected, the user will proceed to the defined workflow steps located just right of the images. Please note 4D-RV function can be used for both 2 and 3D datasets. Beginning with view adjustment in the upper right-hand corner, the user will refer to the landmark reference guide and confirm and/or place the landmarks in their appropriate position by using a drag and drop method. We want to essentially mirror the reference marks in the actual images in the center stage. Next, we're going to select Boidal revision, followed by tracking revision. Here, as you can see, the user has access to all calculated data and can also visualize the reconstructed model. Different layout options are also available, including the diastole, systole, and both diastole and systole. The proposed contour can also be edited in the event that editing is required. Once satisfied with the contour, the user will now select analysis as the final step. The analysis page provides a comprehensive array of analysis data including volumes, function, and the longitudinal strain values for both the free wall and the septum. 2D automated measurements like the fractional area change and TAPSE are also available and can be edited. The user also has the ability to perform manual measurements if so desired, beginning with distance, area, curve, and angle. Exporting options include save bookmark, save secondary capture, save the image or clip, and by the 123 export option that will allow you to export all data into an Excel sheet or CSV file. And last, export Boidal. And now we have arrived at our question answer portion of the presentation. Please feel free to type your question in the empty text field just beneath the chat field. Okay, the first question, can the RV software be used with TE data? Yes, 4D-RV function can be used for both transthoracic and also transesophageal echo. And we have another question. What is the required frame rate for the analysis? With 4D-RV function, the recommended frame rate is 10 Hz per heart cycle or greater. Can the user edit the contours? Yes, this is absolutely possible. We do recognize the fact that the world of echocardiography is an imperfect world and directly related to the quality of the images. So in the event that editing is required of the proposed contour, the user can indeed edit the contour. And last question, can the software be used with pediatric images? Yes, the software can also be used in pediatric cardiology if the image quality and frame rate are sufficient. Let's see, we have one more question maybe. Maybe not. I don't. So this now concludes our webinar. Thank you for attending, and for more information, please feel free to visit us at www.tomtech.de. And you can also find additional courses at the TomTech Academy website, as you can see before you. Thank you, everyone, and have a great day.